So we have come back to the presentation again, and as I told you that we will start with a new algorithm which is random forest. So what is the reason for this particular naming? It will be very clear to you once we will proceed. So first of all, what a random forest is? Random forest is a classifier that contains several decision trees on various subsets of the given dataset and takes the average to improve the predictive accuracy of the dataset. So question is that in a very nutshell, it's a combination of more than one decision tree. So the whatever we have seen previously, the decision tree concept is very closely attached with this algorithm. First point. Second point is, now naturally question will come that why we already have a decision tree and we are using multiple times this decision tree to create a forest. So what is the need of that? So definitely there is some limitation, and that's why you are actually planning for keeping more than one decision tree. So remember, the formation of the tree in case of decision tree is actually highly biased with the training data. Okay, so highly biased means it can start overfitting, and obviously you know it has a very high variance. So it is very difficult to create a generalized model with the decision tree. Now why I am saying this, let's take an example to understand the limitation of this decision tree. Just assume a scenario. You already have seen a decision tree algorithm, and decision tree looks something like this, right? And this is the data set, suppose. Okay. And based on this data set, this decision tree is created, which is dependent upon the feature that we are selecting for this node as well as their criteria, right? Already we have seen that. Now let us take a some some create, let's create a noise in the dataset. The noise in terms of, you see, create a noise like this. What noise you see? If you compare the the highlighted part, the second row, initially we had 3.9, 6.1, 5.50. I mean, first three is the feature, last one is the class. Instead of 3.9 and 6.1, the value of the feature x1 and feature x2 has changed. The class remains same and the x3 feature value remains same. But because of that, because of this particular change in the data set, you will see the tree formation will change a lot. So that means, from this example, what we can understood, we can say that decision tree is very highly prone to the outliers. This is an outlier, you can say, right? Or some noise. And this is a very major limitation in decision tree. How to solve this? Here the random forest come. So why forest? We all know forest means lot of trees makes a forest. Here also we will create lot of decision tree, and based on that we will somehow decide in which class it should be. But question is that if I create a decision tree with these criteria or maybe some other criteria with the same data set, then basically it will almost remain same. So how to do this? Here are very interesting changes will come that we have possessed in random forest. So let's see. It looks something like this. So we will take this two major step in random forest. One, create bootstrap database dataset and random feature selection. Obviously, the point is not very clear to you. I will make it clear. So it's like, just assume that you have the full dataset like this, right? This is the whole dataset. What we will do, among this whole dataset, we will choose some set of rows, not all, some set of rows, and we'll create a sub dataset. Okay. So here, for example, I have chosen this one. Now, one more thing you see here, in this sub dataset, not only I have chosen some few rows among from the whole full dataset, but also we have chosen few columns from the full dataset, not all the columns even, right? So we have a change from both direction. Direction from x means the number of row, and also direction from y, that is the number of features. Now here you see, if you closely see, we have some change, we have some rows 4.3, I mean some random rows presented here. Let's go for another subset. We have something like this, where a very interesting thing you will see, observe that we have the same row repeating in the subset set. Is it by mistake? No, it is not by mistake. This is a special type of, you can say, random sampling, which we call random sampling with repetition. What does it mean? It means that, just assume we have, I've told you to select one of the row at a time, one row at a time. When, and you do this by 4 times. So when you are doing 4 times, it does not mean that whatever row you have already selected will never come next time. It's not like that. There can have a repetition, of the row in the sub data set. And what benefit we can get here? The benefit is that because of these 4, this is now a data set, an independent data set, and this is now an independent data set, right? And similarly, we can have one more independent data set like this. For all these 3 independent data set, 3 independent decision tree will be created. And those 3 decision tree will not reflect the decision tree of the whole data set. Why? Because I have chosen some of the rows, not all. So naturally, the decision tree that will be created from this data set will not fully generalize the actual data set. Even the decision tree created from next subset will not fully generalize this one. So they, by repeating, by creating this type of sub data set, we are actually trying to make the decision tree independent to the original data set. Also, in other side, if you look into the features in the sub dataset, you will see that the features are also not exact same for all the dataset. In one it is x1 x2, in another subset it is x1 x3, in another subset it is x2 x3, something like that. And because of this different features we are given, naturally the decision tree that will create here will depends upon the features, only on these features. The decision tree that will be created for this subset will basically reflect the features of x1 and x3. As a result, what will happen? The correlation between two decision tree will be minimized. If you have a similar features for two different set, same features actually for the two different set, the decision tree that will be created for two different set will be almost similar, because of the correlation between, we have a same data set. So what basically we are doing, we are actually trying to minimize the correlation between the features and the decision tree. So as a result, what will happen? These are the three, in my example it is 3, maybe in real life it can be 30 to 300, and for each and every subset we will have 3 different decision tree. It's for decision tree for model 1, say we can have a decision tree for model 2, and can have a decision tree for model 3. Now question is that if a new point come, then what will happen? If the new point come, then it will be passed to all the decision trees, because we don't know, by mistake it is written x4. Don't be confused, this should be x3. Okay, so x1 x2 x3. So this data set will fully pass to decision tree model 1? No, not possible. It will take only the x1 and x2 and passed here. Then it will take x1 and x3 and it will pass to the next decision tree. Something like this. In this way it will move on. And based on the feature values of the new point, all this decision tree will basically put their opinion. It should be 1 or 0 or something like that, and then the majority voting will come. What majority voting means? It's simply like, assume that you have 5 decision trees. Each and every decision tree will predict some class of that particular data set, particular data point, based on the feature values. Among 5 decision tree, whoever will, the vote that for a class 1 or class 0, whoever is the measure will be considered as the final output. If among these 3 decision tree, if 2 decision tree say 1 class 1 and another is say class 0, because of majority voting on class 1, the new data set will be considered of that particular class, which is class 1, which is basically the classification result. Okay, so now question is that again the similar question we repeat, that why ultimately we are going for this bootstrapping. What is bootstrapping? This is bootstrapping. We are creating some subset of the data. Maybe there will be some repetition of the rows. Okay, so naturally question comes that why bootstrapping and this feature selections, that what I was just discussing. So this bootstrapping and feature selection ensure that the same data is not being used by every tree, what I was saying. If you have a same data set for tree, so naturally you will have a very similar decision tree. So basically it will not basically able to manage the outlier or noise present in the tree, because the tree is same almost. Similarly, naturally questions come that how many features to consider, like I mean basically question should not be how many features to consider, it should be what is the benefit of this different small, subset of features we are using, that is helps to reduce the correlation between the trees. Just what I said, like if we have a very similar number of features, naturally the tree is also same. If we have different features, the tree structure will be different, and there will be very less correlation of the tree. So the data learning will be much more generalized. So naturally, if you even have some outlier in the data set, that outlier will not affect the learning of the tree, and you will not have any effect in the result. So this is what random forest algorithm is. I'm not going in much detail because you all can understand this random forest is nothing but a extension of decision tree algorithm. So what already you have seen decision tree. So there is nothing new to discuss here. But what we can do, we can go back to the code again and we can see what's actually way of writing the random forest using Python code. Using some package. Let's see.